Hello friends, we will be going to discuss electrical analysis, role of the finite state automata in electrical analysis, design of electrical analyzer. So, what is electrical analysis? We all know electrical analysis is the very first phase in a compiler design. A lecture takes the modified source code, which is written in the form of the sentence. In the other words, it helps you to convert the sequence of characters into the sequence of tokens. The lexical analyzer breaks this sentence or the syntax into a series of tokens. It removes any extra space or the comment written in the source code. So programs that perform the lexical analysis are called as the lexical analyzers or ledgers. A ledgers contain the tokenizer or the scan. If the lexical analyzer detects that the token is invalid, it can generate the error. It reads the character string from the source code, checks for the legal token, and pass the data to the syntax analyzer when it remarks. So in this way, the lexical analysis is work. So as shown into the diagram, lexical analysis contains the source code, which is passes the lexemes, that is nothing but the tokens, to the lexical analyzer. Lexical analyzer transfer that tokens to the syntax analyzer whenever the syntax analyzer requests for the token. So in this way, the lexical analysis is work. So for example, the input is given to the program as a result is equal to a plus b into a. So how the token is generated? So token contain how many tokens into that? First token is the result, second one is the equal to sign, then third one is the a, then fourth one is the plus sign, fifth one is the b, sixth one is the star, and seventh one is nothing but the text. So there are the different types of the token. So some tokens are nothing but the identifier, some operator, etc. etc. So as per that, from the program, result A, B, and 10 are nothing but the identifiers, and equal to, plus, and multiplication are nothing but the operator. So in this way, the lexical analysis is taken. So how we use the finite state automata in a lexical analysis? What is the function of finite automata? So finite automata is a state machine that takes a string of the symbols as input and changes its state accordingly. So the finite automata is nothing but a recognizer for the regular expression. Then that regular expression string is fed into the finite automata. It changes its state from each literal. If the input string is successfully processed, then the automata reaches to the final state. It is accepted. So in this way, the finite automata work. After that, this finite automata uses a mathematical model. That mathematical model contains finite set of states, which is represented by Q, finite set of input symbol, which is represented by summation sign, one start state, that is nothing but the Q0, final state is nothing but the Qf, and transition function is represented by the delta. So that delta will map the finite state of state Q to the finite state of the input symbol as shown into the diagram. Means Q into summation is referred to the Q. So the finite automata construction contain the LR. L of R is nothing but a regular language recognized by the some finite automata. So that some finite automata contain the states start state, intermediate state, final state, and transition. State is nothing but the which is represented by the circle. State name are written inside that circle. Start state is nothing but that the state from where the automation is started is known as a start state, and it has an arrow pointed toward it. Intermediate state is nothing but they having at least two arrows, one pointing to the another pointing to the out, means in and out. These both arrows are required for the intermediate state. In the final state, whenever the string is successfully passed, then that time it is expected that this is the final state. Then the final state is represented by the double circle. Okay, and transition. Transition is nothing but the linking from the one state to the another state. Okay, so in this way, and it is represented by the directed arrow. So in this way, the finite automata construction will be takes place. So finite automata construction example is as shown in the figure. Under this example, we assume that finite automata accept any three-digit binary value ending in digit 1. So for that, initial state is represented by Q0 and last state is represented, final state is represented by Qn. Then that particular, the condition explained into the example is nothing but the ending state is nothing but which is end with the digit 1. So Q0 to Qf, there is 1. So this is nothing but the final state. Hence, double circle to that particular final state for representation of that final state. Also, the self loop is also there for representing the final state as shown into the expression. So this particular regular expression is represented by the finite automata as shown into the figure. Design of lexical analyzer. As we know that the lexical analyzer is nothing but the program that perform lexical analysis are called as a lexical analyzer, or it is also called as a lexer. It contains the sequence of tokens. After that, lexical analysis can be implemented with the deterministic finite automata. After that, it will also contain the parser for the syntax analysis. So the diagram contains lexical analyzer take the input, which is nothing but reading by reading the character by pushing back extra character. After that, lexical analyzer will generate the token, which is asked by the syntax analyzer. In this way, lexical analyzer is work. So this design of the lexical analyzer contains the token. So token is nothing but the sequence of the character that can be treated as an unit in the grammar of the programming language. Example of the tokens. That example contains type of the token, whether that token is the ID, number or real. Punctuation of token, that is nothing but it uses some if condition, void, return, etc. etc. And alphabetic tokens are also called as a keyword. That alphabetical token having the four criteria: keywords, identifiers, operators, and separator. We know keyword is nothing but the for, while, if, etc. Identifiers are nothing but the variable name, function name, etc. Operations are nothing but the plus, minus, into, summation, etc. etc. Separation are nothing but the comma, semicolon, etc. There are also some non-tokens into the program. That is, non-tokens are nothing but comments, preprocessor directives, micros, blanks, tabs, new line, etc. Now, what is the lexeme? The sequence of character matched by a pattern to form the corresponding token or a sequence of the input of character that comprises a single token is called as a lexeme, and that lexeme is denoted by float absolute 0 Kelvin equal to minus 73 and colon semicolon. So how the lexical analyzer will be work, or what is the function of lexical analyzer? First function is nothing but the tokenization. Under that tokenization, it will divide the programs into valid tokens. After that, second function is nothing but it will remove the white spaces character. Third one is it remove the comments, and fourth one is it provide the help in generation of the error message by providing row number and column number. So all specification about the error is provided by the lexical analyzer. So this lexical analyzer identify the error which help for the automation machine and the grammar of the programming language on which it is based, like the C++, and gives the row number and column number of the array. Suppose we pass the statement to the lexical analysis, that is nothing but the A is equal to B plus C. So it will generate the token sequence like this: ID is equal to ID plus ID. where each ID refers its variable in the syntax. So the example for the lexical analyzer is given to the program slide. One small C program is there, and all valid token under that C programs are generated. As previously we know, similarly we can find out the token. Blank spaces comments are not count under the token activation. So that's why int main opening brace, closing brace, opening curly brace, then integer a comma b semicolon, again a equal to 10 semicolon, return 0 semicolon, and curly closing brace. All that are nothing but the tokens. So in this way we study the different type of we study the lexical analysis, design of lexical analyzer, and how the finite automation is used for the lexical analysis.